Today we're going to look at climate and context, thanks to the Knowledge Action Network, CON. And we're going to specifically be looking at climate data in Monterey, California, and across the United States for the purpose of constructing high school and undergraduate curriculum to start a conversation about what active learning and climate looks like. If you think back to a traditional lecture hall, it probably looks something like this, where you had a sage on the stage and you had students who were passively listening, perhaps taking notes, but not necessarily engaged in the work itself. Data has shown that students now are far more successful in the classroom when they are engaged in active learning strategies. In fact, when we think about what we want our students to do when it comes to climate work itself, we want advocacy. We want students to grow and cultivate the knowledge, skills, and engagement to make them effective participants in the work itself. How do we do that? Well, if we think about engaging our students, we could start with some very simple questions. What was the average temperature in October in 2010? I've had students say anything from 50 degrees to 85 degrees. And if I ask them about Monterey, California specifically, what do you think will be the average temperature in October 2020? They might say, I don't know, 52 degrees, 57 degrees. And then if I ask them to predict what the average temperature will be in October 2050, there's been a wide variety of answers from students. But you might be wondering, why are we talking about engagement to begin with? Well, engage is part of the 5E model, and that is a way of accessing prior knowledge. So when we engage students, we're asking them, what do you already know? What are you coming into this learning environment with? From there, we're going to be looking at how do students explore? So how do they access new information or construct new knowledge based on their experiences? And then we're going to ask students to explain. We're going to ask them to use claim-based reasoning, where they're going to use evidence to support a claim. And then there will be an opportunity to extend or elaborate this new knowledge that students are constructing. And then because we as educators want to learn and grow and determine the best ways to cultivate student engagement, to cultivate student achievement, then we're going to use some form of evaluation to determine what did students actually learn. If we think about how we explore, then the next thing that we're going to be looking at is the toolkit Climate Explorer. And we're going to search by location, and we're going to look for a couple of things. We're going to enter our home address zip code. We're going to describe the first graph that we encounter. We're going to be looking at what the x-axis is and what the y-axis is. And then we're going to take a moment to unpack what the red and blue colors mean, and what are the red and blue bold lines, and then what's a median. So if we think about the Climate Explorer, there are a couple of options that we have here. We have temperature and precipitation. We also have access to weather stations. But the first thing we're going to look at is that this is a graph of temperature. And on the side, I can see that I have some choices. I have annual temperature, I have monthly temperature, and I have seasonal temperatures. And then there's the mean daily minimum temperature. So I have to think back. And if I'm not sure what mean is, that's something I could always look up. Mean daily temperature, the days with a maximum above 95 and the days with a minimum below 32 degrees Fahrenheit. So if I look at the graph itself, I can see that on my x-axis is time. That's time specified in years. And I can also see that my y-axis is the mean or the average daily maximum temperature. So they asked about the red and the blue. So the red shades look like higher emissions. The blue shades look like lower emissions. And then I have these medians where I have a bright red line and a bright blue line, and those represent the middle number for each of those measurements. So this is for Monterey County. I can see that there. So let's take a look at Explore Part 2. So we have to go back to the first graph that we encountered to answer the engaged questions. What was the average temperature in October in 2010? What do I think will be the average temperature in 2020? Predict what the average temperature will be in 2050. So we're going to go forward for a moment to try and answer those questions. So the beauty of this is that students have already made a prediction. They've said, this is what I think it will be. And now, using the model, they can actually think about that data. So what was the average temperature in October? Well, I've got to find October. I'm up and I can see, okay, it was about 76. Okay. That's the current measurement. But now maybe I want to go back and I'm going to say, okay, in my Climate Explorer, that very first graph that I saw, that first graph also had some predictive values at 2020 and at 2050. Now, I'm not certain because these are the mean daily temperatures, not necessarily for October, but I can say, okay, I'm going to see some change in the 70s, but I can notice that there's an increasing trend when I get to 2050. And that's a great opportunity for students to start to ask questions. But there are some other pieces of this data that we want them to pay particular attention to. What's a range? It's all of the possible values that are observed for that measurement. So if I'm thinking about a range and I want to think about the data that I've seen so far, the range that I'm looking for is the difference between the lowest and the highest values. So if I use a range to answer the questions, well, maybe that's because I'm not certain what the actual number will be. Maybe that's a place where, as a student, I can explore what it means to have uncertainty in a given measurement. And then the next piece is there would be a great opportunity here to have students turn and talk, to think, ink, pair, and share, where they would think about, okay, what were my predictions when I first answered the questions? Did those predictions line up with the data that I saw? And then, were they similar? Were they different? Why or why not? So if I think about the utility of using the data itself and having students explore the data, one of the things I'm quickly going to begin to see is that students arrive at the idea that there is climate change that they're observing simply by analyzing the trends that they see. Now, we don't want to stop there because students have just begun this beautiful inquiry process. We'd really like them to dig in a little further. And so we're going to look at Explain. And in Explain, we're going to have, in small groups, students to brainstorm on a whiteboard, or maybe you want to do 2-minute interviews where you pair students up and you have them talk about, what might there be as reasons for differences in temperature over time? Or does the rate of the temperature change increase or decrease? Why? These are great opportunities for students to start to dig in and think about, what's a claim I can make? What's the evidence that I can produce to support that claim? Another way that you could look at this with students in terms of the Explain is to look at extreme heat. Again, we can go back to the toolkit and we can look at a map of the United States. And you can actually have students start to think about, using a mind map or some other tool, how human beings combat extreme heat. So this is an example of a mind map. It's behavior change for combating climate change. And there are a variety of responses that are here. This would be an example that you could use to show students And then you could give them the center topic of how do humans contend with extreme heat. You could use an example of, say, for example, the country India, right? And their hottest days at 120 degrees. And so maybe that would be a great starting point to say, okay, if you were experiencing that, or maybe that temperature in the middle of the Mojave Desert in California, how do you contend with extreme heat? It's a great place to start the conversation. Once students have started to provide evidence to foster a claim, then it's worth thinking about where could you go next? So we started in Monterey, California, because that's where our students call home. But it's worth it to have them think about where else in the country do people experience climate change? Is it only in California, or do we see it across the United States? Or across the nations? Maybe to a place that I've visited or a place I've always wanted to go, or maybe to a place I've never heard of. You could also elaborate by having students think about sea level rise. What happens when the temperature increases? Is that correlated with any other types of changes that would impact human life? NOAA has a wonderful sea level rise viewer where you could look at potential coastal flooding, impact areas, and the relative depth. You could have students take their current knowledge and expand that to include sea level rise. Or as an elaboration strategy, you could have students select one of the following resources and explore the causes of climate change. So maybe this is an instance where students have done their exploration initial activity, they've developed some evidence and claims, but you'd like them to dig a little bit deeper. These are some phenomenal resources. But maybe that's a level of maturity and independence that your students haven't yet fostered. So maybe you want to model for them what that looks like. These are two resources for teachers that actually help cultivate an understanding in students of climate change. But maybe your students are so engaged that they want to dig a little bit deeper, or maybe you want to help them continue to construct knowledge through a homework assignment or through a group assignment. These are some options, whether it's topics themselves for discussion, case studies to investigate, specific training courses if they wanted to obtain more information, or the actual reports themselves that are produced by scientists who spent their careers studying these topics. Once you've elaborated and kind of helped students start to construct even more knowledge, now as an instructor, you want to determine, well, what did they really learn? This is where we can look at climate model analysis, solutions, and productive discourse. We can evaluate future changes to temperature, precipitation, and sea level for somewhere in Monterey County. You can have students select a different zip code. You could have them repeat this analysis for another city in the United States, Houston, Texas, or Miami, Florida, or Lincoln, Nebraska, or New York, New York. You could then have students answer the following questions. How might you explain the difference between weather and climate? And then based on your explanation, would you expect the climate models to be able to predict whether 2020 would be a warm year or a cool year? And then do you think that the climate models would be able to predict whether the period from 2020 to 2040 will be warmer than the period from 1990 to 2010? These are all questions that are designed to see whether or not your students learned the skills to both access that data, but also cultivated the critical thinking and the quantitative reasoning to start to provide evidence for whatever claim they're going to make. If you wanted to evaluate further, you could actually look at the representative concentration pathways. we want students to think about how to design solutions. So if you were the president's science advisor, what are the top 3 solutions that you would recommend? To reduce greenhouse gas emissions and move the world off RCP 8.5 pathway and onto a lower pathway, how quickly or extensively do you think your solutions would need to be implemented? How would you argue for your recommended policies? So at this point, when we're thinking about designing solutions, we really want students to start to consider how to affect change. It's helpful for students to have a final deliverable. So consider your final product will be a script of your discussion with a climate change skeptic. The goal of this curriculum is to start a conversation, but to realize that in order for students to grow in their understanding and develop the skills necessary to implement change, they need to access their prior knowledge, explore new ideas through inquiry or hands-on investigation where it's the student who's doing the analysis, develop the ability to explain what they know, start the process of elaborating or further developing that knowledge, and then evaluating what is it that they know at the end of the day. This is a method that can be used to explore climate and context in Monterey, California, or in your hometown. Thanks again.